The discovery made by the James Webb Space Telescope has captivated scientists and the public alike. The telescope detected lights that appear to emanate from a city shining brightly from a distant point approximately 4 light-years away. This remarkable observation has reignited interest in the possibility of extraterrestrial life. The telescope focused its observations on Proxima Centauri, the closest exoplanet to our solar system, and detected mysterious, bright flashes that raised the tantalizing question: could they be signs of an alien civilization? For years, scientists and ordinary people have eagerly speculated about life beyond Earth. Any evidence suggesting the existence of something beyond our world has always been met with excitement. Now, the James Webb Space Telescope has provided a potential turning point by delivering clear indications of possible life elsewhere in the cosmos. While scanning the depths of space, this powerful telescope observed something extraordinary on Proxima Centauri, a distant exoplanet. The telescope captured lights resembling those of terrestrial cities, sparking the possibility that an extraterrestrial civilization might exist on this planet. This idea has generated tremendous enthusiasm among scientists who are intrigued by the implications. The discovery could indicate the presence of intelligent beings who may have organized their societies in ways that are just beginning to be understood. The city-like lights located in incredible 4 light-years away have left NASA engineers astonished. The question arises of how long these lights might have been visible in space, waiting for human technology to evolve enough to detect them. David Kipping, an astronomer at Columbia University, described Proxima Centauri as a particularly complex planet. Unlike most rocky planets that absorb sunlight and emit energy as infrared radiation, this exoplanet exhibits unique behavior due to its dynamic relationship with its parent star Proxima Centauri. The James Webb Space Telescope's ability to capture infrared wavelengths was instrumental in detecting the unusual activity on Proxima Centauri, making it crucial for understanding the atmospheric conditions of this intriguing world. Researchers plan to continue using the telescope to study the planet's atmosphere in greater detail and to investigate its potential habitability. The telescope's remarkable sensitivity to infrared light allows it to observe what happens on Proxima Centauri during its nighttime. For many telescopes, detecting faint light in the vast darkness of space is challenging. However, the James Webb Space Telescope excels at picking up even the faintest glimmers of light, making it an ideal tool for confirming whether the supposed city lights on the dark side of Proxima Centauri are real. The telescope can detect artificial light in space if it exists within a very narrow frequency band, much narrower than the light emitted by normal stars. Proxima Centauri's relationship with its star is dynamic. One side of the planet captures intense solar energy, while the other side reflects light as it revolves around Proxima Centauri, experiencing day and night cycles similar to those on Earth. These cycles lead to significant temperature variations, which are influenced by the planet's composition. If Proxima Centauri lacks an atmosphere, the temperature differences between its day and night sides would be extreme. Without the moderating effects of atmospheric gases or oceans, the day side would experience intense heat, while the night side would plummet to sub-zero temperatures. These dramatic thermal variations provide valuable clues about the planet's atmospheric composition. The James Webb Space Telescope's ability to observe Proxima Centauri's thermal emissions is instrumental in analyzing its atmospheric properties. Interestingly, the telescope's orbit around Earth aligns with Proxima Centauri's orbital period, allowing detailed observations of its day-night cycles every 11.2 Earth days. If the planet has an atmosphere, researchers will examine its chemical composition to assess its potential to support life. Indicators such as oxygen, water vapor, and methane would suggest habitable conditions. Detecting these elements would involve analyzing the light passing through the planet's atmosphere, a complex task for which the telescope is well suited, although primarily designed for other functions. The James Webb Space Telescope can detect variations in concentrations of water, vapor, carbon dioxide, and methane, offering insights into the planet's habitability. While the telescope excels in characterizing planetary atmospheres, it faces limitations in detecting free oxygen, a crucial biosignature. Nevertheless, it can search for other elements such as ozone, which would indicate a healthy atmosphere. As scientists analyze the data collected by the telescope, the search for distant worlds continues, bringing humanity closer to answering the profound question of whether we are alone in the universe. It is important to note that the James Webb Space Telescope can only observe a limited number of exoplanets close to Earth. For detailed atmospheric studies to expand this capability, astronomers will rely on ground-based observatories like the extremely large telescope ELP, which is set to be operations in 2028. The YELI will provide a deeper understanding of the atmospheric structures of distant exoplanets, offering clearer and more detailed data about their potential to harbor life. Future space telescopes are also being developed to overcome existing challenges and improve our ability to study distant planets. One of the major challenges in observing exoplanets is the brightness of their parent stars, which often outshines the faint light reflected by the planets. To address this, scientists are developing innovative techniques such as coronagraphs and starshades. Coronagraphs are devices placed inside telescopes to block out starlight while allowing light from planets to pass through. By carefully shaping light waves, coronagraphs can significantly reduce the glare from stars, making it easier to detect the faint light of exoplanets. Another promising technology is the starshade, a giant flower-shaped spacecraft that flies information with a telescope positioned tens of thousands of kilometers away from a telescope. The starshade blocks starlight before it enters the telescope, allowing only the light from exoplanets to reach its instruments. These technologies require extraordinary precision. For instance, aligning a starshade with a telescope demands accuracy to fractions of a millimeter over vast distances. Additionally, these advancements must overcome challenges such as miniaturization, energy efficiency, and the harsh conditions of space. Despite these difficulties, the potential rewards are immense. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of signatures, chemical indicators of life, molecules such as oxygen, methane, or water vapor in specific ratios could hint at biological processes suggesting that life might exist beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes equipped with advanced adaptive optics could adjust for distortions caused by Earth's atmosphere or telescope movements, producing sharper images. Combined with starlight blocking technologies, these improvements could enable scientists to not only detect exoplanets, but also map their surfaces and study their climates. The development of next-generation space telescopes represents a significant leap forward in humanity's quest to answer one of its most profound questions: are we alone in the universe? By enhancing our ability to observe distant planets, we edge closer to finding out if life exists beyond Earth. Such discoveries have the potential to revolutionize our understanding of our place in the cosmos and reshape our perspective on the universe. The James Webb Space Telescope continues to push the boundaries of astronomical exploration, revealing the universe in unprecedented detail. Its recent findings have sparked renewed enthusiasm in the scientific community and among the public, bringing us closer to answering questions that have fascinated humanity for centuries. As the telescope gathers more data, it becomes increasingly clear that its capabilities are paving the way for discoveries that could transform our understanding of life and the cosmos. One of the most exciting aspects of the James Webb Space Telescope is its ability to study exoplanets in detail, particularly those located in the habitable zones of their stars. These are regions where conditions may allow liquid water to exist, making them prime candidates for hosting life. Proxima Centauri, for instance, is not only close to Earth but also falls within the habitable zone of its parent star. The detection of potential city-like lights on its surface raises fascinating possibilities. Such lights could indicate artificial structures or technology, perhaps the hallmarks of an advanced civilization. However, the interpretation of such data requires caution. Natural phenomena such as bioluminescent activity or geological processes could also explain the observed lights. Scientists are meticulously analyzing the telescope's observations to rule out alternative explanations. The methodology involves studying the spectral signatures of the light, comparing them with known natural and artificial light sources, and conducting follow-up observations to verify the findings. This rigorous approach ensures that any